This is a nice cute power supply. It takes 230 volts AC. There is also option for 115 volts, and input current maximum is 1 ampere at 230 volts and 1.2 ampere at 115 volts. It has 5-volt output. You can see that this is the live and neutral connections here. You can see two connections, and there is one ground connection, and you have V plus and V minus outputs. And there is a preset potentiometer over here. That is, you can turn the screw and adjust the output voltage within a short range. So to use it, you have to wire it, and then you can check the voltages. I'll do that shortly. Now I have connected a power cord. The screws here were removed using this star-edged screwdriver, and then I have connected the wires here. You can see the color coding. The live one is the red wire and the neutral is the black wire. That is the usual coding for connecting power cords. Now I have used a plastic tape to cover off the region of the main supply because I don't want to be touching that accidentally and getting a shock. And using the same star-edged screwdriver, I have pulled out these screws and then connected two wires over here. This has been connected to the positive supply and this to the negative supply. Negative has been given a color coding of black. You can see V minus and V plus. Now we will see the input and output voltages of this transformer, or rather power supply. Now I am measuring the input voltage. That is shown as a little bit high, maybe because it's morning when there is no load to the power supply, main power supply. Instead of 230, it is showing almost 240 volts. As I have already put the tapes here, I am just checking the supply voltage. Now I am measuring the output voltage using a pair of crocodile clips to connect the output to the multimeter, and you can see that the range has been changed. Earlier it was in 750 volt AC range, and now it has been put in the 20 volt DC range, and you can see that the output is being read as 5.2 volts. 5.2 volts is the output without load. I have not connected any load. If you connect a load, maybe it will come down to 5 volts. Initially I had mentioned that this is a 5 ampere power supply, that is 5 volt 5 ampere. So when 5 amperes of current is being drawn from the output, maybe this voltage will come down a little bit, maybe by 0.2 volts or so. I am not very sure, I have not checked it. Now there is a preset potentiometer here which can be used to adjust the voltage, output voltage, and we'll see what happens when I turn that preset potentiometer. You can see that I have placed the screwdriver, or rather tester, line tester, which acts as a screwdriver in the slot of the potentiometer, which is now in the 0 degree position. I'll try turning it. I am turning it counterclockwise. See what happens to the output. You can see that output is gradually decreasing. It is gradually decreasing to, now it has come to 5 volt, almost 5 volts. The output has come to 5 volts. I'm still turning. It is going down further. So now I am at 90 degrees in the counterclockwise, and the output has come down from 5.2 to 4.95 volts. Now I will turn it the other way around in the clockwise direction. Now it has come back to 5, and I am turning it further. It is increasing gradually, 513, 5.13. Now it is the old 5.2. Now it has increased still beyond that, 5.4, 5.5, 5.6. So this is the range of this preset potentiometer. You can change it either way. So I'm bringing it back so that I can have the output at 5 volts. You can see that it is coming down. Now the output is 5 volts. 5 volts is the usual standard requirement for USB power supply. And many of the circuits nowadays for breadboard circuits are working on 5 volts. So this power supply will be useful to connect to such breadboard experimental designs. That's the utility of this power supply.